Hello and welcome to lesson 2.5, geometric proof. Last lesson we looked at algebraic proofs, which really just involved giving the reason for each step you were making. Today we're going to look at the slightly more complicated geometric proof, and really it's only more complicated because it's much more theoretical. So basically, geometric proofs are going to prove theorems to be true, and a theorem is a statement, usually in the form of a conditional, that has been proven to be true. By contrast, a postulate or axiom is a statement that we accept to be true without proof. We've already studied a couple postulates, like the segment addition postulate, which you remember was part plus part equals whole in Unit 1. So you've already run across postulates, and postulates are just things that we assume to be true. Unlike a postulate, we have to prove theorems. We can only use postulates and theorems that we've already proven to prove new theorems. So, the basis of all, the framework of all proofs is the conditional statement. I should be able to write all theorems in a conditional form, where the hypothesis of my conditional statement represents my givens, and the conclusion represents my thing that I'm going to prove in the theorem. So let's take a look at an example. We're going to start off by proving the vertical angles theorem, and the vertical angles theorem states if two angles are vertical angles, then they are congruent to each other. So my hypothesis is two angles are vertical angles, and my conclusion is that they are congruent to each other. So before we begin this proof, we probably want a diagram to give us a point of reference so that our proof doesn't take 3 pages to write. I always look at the hypothesis to determine what kind of picture to draw. This picture, I need two angles that are vertical angles. So I'm going to draw two vertical angles, which remember vertical angles occur when I have two lines that cross each other, like so. And I'm probably going to label my angles, angles 1, 2, 3, and 4. And I'm going to choose one of my pairs of vertical angles to prove. I'm going to, in this case, prove 1 and 3. Okay. Now, things I'm seeing in this diagram that are helpful, I see linear pairs, which I like because I know linear pairs sum to 180 degrees, and that's something that I can do really easily. So I'm probably going to use linear pairs when I'm proving this statement. So let's get going. I'm going to pause the video real quick and just fill in the blanks here, so give me a second. So here you can see I've reproduced the diagram we had before. And now rather than writing two angles are vertical to each other, I write specifically angle 1 is vertical to angle 3, and that I want to prove that therefore angle 1 is congruent to angle 3. I have to give myself this framework in order to do the proof more easily. So my first statement is my given. Angle 1 is vertical to angle 3. That's my given. And if you recall, we started off by saying that we're probably going to use linear pairs to prove this. Well, I'm definitely going to do that. I'm going to say right here that angle 1 and angle 2 form a linear pair. And again, that angle 2 and angle 3 form a linear pair. I am not going to need angle 4 in this proof because I already have enough to go with from here. I'm going to keep it as simple as possible. So what allows me to say this is that this was given, given in my diagram. Because I can pull that those are linear pairs right off my diagram. And we know that if two things are a linear pair, then we know that they add up to that they are supplementary. So I would say angle 1 is supplementary to angle 2, and angle 2 is supplementary to angle 3, And this is my definition of a linear pair. And I can then say, because they're supplementary, they add up to 180. So measure of angle 1 plus the measure of angle 2 equals 180. And the measure of angle 2 plus the measure of angle 3 equals 180. And this is by the definition of supplementary. Now, I now have two things that are equal to the same number. And so when that happens, it's a telltale sign that I can set them equal to each other. So I would say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. And I'm able to say this by the transitive property of equality. So transitive property of equality. Now I like this because if we look, these two things here and here are the same. I have measure of angle 2 on both sides, which means I can subtract that off from both sides of my equation to leave me with the measure of angle 1 equal to the measure of angle 3 by subtraction. Property of equality. And if two things are equal, that means that two things are congruent. Angle 1 is congruent to angle 3 by the definition of congruent. Now, I'm officially done with my proof, and I know that I'm done with my proof because I'm ending with the same thing that I was asked for up here in my proof statement. So my last line is always this statement right here, okay, that proof statement. So just know that. Let's take a look at another one. So now let's take a look at proving the linear pair theorem. Now, the second theorem we're doing is looking at linear pairs and is basically saying that two angles that form a linear pair are, in fact, supplementary. It's going to be a wonderful shortcut for us in the future, but of course we can't use that shortcut until we prove it. So we always start with our givens. Angle 1 and angle 2 form, with an M on the end, a linear pair. And that's my given. And step 1. Now, definition of a linear pair is basically two adjacent angles whose sides form opposite rays. So I then need to say in my next line that CA, ray CA, and ray CB are opposite rays. And that's a good thing because opposite rays form straight angles, and straight angles have 180 degrees, and we have to add up to 180 degrees to be supplementary. So this is my path. I just have to be really, really specific about how I go down it. So I'm able to say that they're opposite rays by the definition of a linear pair. So guys, those wonderful vocab charts you started making, you're going to reference them a lot when doing these kinds of proofs. All right. And we like opposite rays because it means that angle ACB is in fact a straight angle. By the definition of straight angle. Okay, and straight angles are awesome because the measure of straight angles must be 180 degrees, again by the definition of straight angles. I am really okay with you guys going through and using the quote marks to stand in for, and I'm repeating this line now because it's the same. I'm fine with that. Okay, now, I want to show now that 1 and 2 create this straight angle. So I'm going to use the angle addition postulate to say that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle ACB. That's my part plus part equals whole. or my angle addition postulate. Angle addition postulate. You're going to use him a lot. All right. And what's more important, though, is that this straight angle here adds up to 180 degrees. So I'm going to plug that in right there. So I'm now able to say in this step that the measure of angle 1 plus the measure of angle 2 must add up to 180 degrees by the substitution method. So substitution, property of equality. And if two things add up to 180 degrees, they are in fact supplementary. So angle 1 is supplementary to angle 2, which if you look up here, that's what I was trying to prove, that they're supplementary. And I'm able to say that by the definition of supplementary. And so I am done with my proof. I'm going to color in my square or write QED. So there you go. Next, we're going to look at the congruent supplements theorem. And the congruent supplements theorem is a lovely, lovely, lovely theorem, and I want you guys to pay close attention to it because your first try me in this lesson is going to be the congruence complement theorem, which is the same proof but with complementary angles rather than supplementary angles. So let's take a look. The first thing we're told is if two angles are both supplementary to a third angle, then these two angles are congruent. And we're going to rewrite it. So if angle 1 and angle 3 are both supplementary to angle 2, then I want to prove that 1 is congruent to 3. So my givens are that 1 is supplementary to 2. So I'm going to draw that. Okay. I have angle 1 and angle 2. And together, they are in fact making a line because they're supplementary. And then we learn that 3 is also supplementary to 2. So I'm going to draw that as well. Okay, here's my angle 2. Well, now 3 is supplementary to 2. And I want to prove that angle 1 is congruent to angle 3. That's my goal. So this side we always write my statements. And this side I write reasons. And we're ready to begin. We always list our givens. And I'm okay with you abbreviating. Angle 1 supplementary to angle 2, and angle 3 supplementary to angle 2. Both of those are given. That is my first step. Then, second step. If two things are supplementary, then they add up to 180 degrees. So measure of angle 1 plus the measure of angle 2 adds up to 180. That is by the definition of supplementary, pure and simple. And we can basically do the same step again, but this time with 3 and 2. Measure of angle 3 plus the measure of angle 2 has to also add up to 180 because we were told that they are in fact supplementary, so by the definition of supplementary. Now, for my fourth step, I now have these two phrases here, boom, equal to the same number, 180. Well, if I have two things equal to the same number, then those two things are in fact equal to each other. So I can say that the measure of angle 1 plus the measure of angle 2 must be equal to the measure of angle 3 plus the measure of angle 2 by the transitive property. And that's property of equality because we're dealing with equal signs. Now, looking at this, I've got an angle 2, measure of angle 2 on both sides of my equation. That means it basically can cancel off of both sides. So now I have that the measure of angle 1 is equal to the measure of angle 3 by the subtraction property of equality. And if two things are equal, they are also congruent. Whoa. angle 1 is congruent to angle 3 by the definition of congruent. And again, my whole goal was to end here. Well, I got here, so I'm done. Yay! So now, guys, I want you all to go through and prove this try me, the I can prove the congruent complements theorem. Really, this is just like the last theorem. So, model it after that. Just be smart about it, okay? You're dealing with complements, not supplements, but I know you can do it. So go and show it to me in class. Let's take a look at one last theorem for the day, the right angle congruent theorem. And I want to show you guys this theorem just so that you realize that not all theorems are miserable, long, awful theorems, okay? Often theorems are beautifully short, simple, and to the point. So my theorem basically says that all right angles are congruent, which is one of those things that you're probably thinking in your head, well, no, duh, they're all 90 degrees, so they're all congruent, right? We have to prove that? Yes, we do have to prove it. First thing I'm going to do is I'm going to rewrite this statement as a conditional. If angles are right angles, then they are congruent. Now, I'm going to draw a sketch of this, and I'm just going to do two angles. Okay, I have an angle that's a right angle here. I'm going to call it angle 1, and then another angle here, also right angle. I'm going to call angle 2. So the thing I'm given are two right angles. I'd be given that measure of angle 1 is equal to 90 degrees, and that the measure of angle 2 is also equal to 90 degrees. And what I want to prove, that angle 1 is congruent to angle 2. That's my goal. So let's get going with statement reason. Well, first things first, I write out my givens. Measure of angle 1 equals 90. That's my first step. And measure of angle 2 equals 90 degrees as my given. Now, if two things are equal to the same number, then they themselves are in fact equal. The measure of angle 1 is equal to the measure of angle 2 by the transitive property. And two things that are always equal are in fact congruent by the definition of congruent. And, well, look at that, guys. I'm already done. I wanted to prove that 1 is congruent to 2. I have proved 1 is congruent to 2 in 3 beautiful short steps. Done. So not all proofs are long. Just to let you guys know, sometimes proofs are very quick, short, and to the point. Now, I want you guys to try this one on your own. I know. It's a challenge. I'm gonna help get you guys started, okay? By setting it up for you, but then I want you to do it on your own. So, if two angles are congruent and supplementary, then they are both right angles. So that's sketch. I have congruent supplementary angles. I'm going to start with the fact that they're supplementary by drawing my supplementary angles as opposite rays, and they're congruent. That means that they're both congruent. Call it angle 1 and angle 2. So I'm given that angle 1 is congruent to angle 2, and that angle 1 is supplementary to angle 2. And I want to prove that these are both right angles. So I'm going to prove that the measure of angle 1 is equal to 90 degrees, and the measure of angle 2 is equal to 90 degrees. So now you're going to come down here, and just like always, you're going to draw your T-chart. with statement and reason. And I do expect you to try this. Finish this problem. Do not leave it blank. If you don't try it, I will take massive points off. I need you to try. Even if it's hard, I need you to try. All right, guys, thank you so much, and I'll see you in class whenever I see you in class. A day, B day, who knows. Thank you.